Please be seated. Well, ladies and gentlemen, this is a rather unusual gathering for an honorary degree ceremony, but we do occasionally confer honorary degrees outside the normal period of the academic year, and especially when we manage to have somebody that we do wish to honor come to Glasgow. And we thought this was a great occasion to combine both an honorary degree ceremony but also a lecture from a distinguished Nobel laureate. You'll hear from me, just let me say a few things about the order of proceedings. We'll first conduct the honorary degree ceremony, and I will be giving an oration for Professor Zewail, and we will then do the formal capping and conferring of the honorary degree. And after that, we will go immediately into the lecture, which Professor Zewail will then deliver to us. So let me start with the honorary degree ceremony. I will read the oration, and then we'll proceed with the award of the degree. So, ladies and gentlemen, by authority of the Senate, I present to you this person on whom the Senate desires me to confer the honorary degree of Doctor of Science, Professor Ahmed Zewail. Professor Zewail recalls the time when, as a boy, he wanted to see the stages of transformation that wood goes through when it burns. And he therefore set about constructing a piece of small apparatus which used his mother's oil burner for making coffee, some glass tubes, and, of course, wood. Now, mindful of the danger that if things went wrong, he would in all likelihood burn the house down, he also remembers the thrill of achieving his goal. Through ingenuity, he was indeed able to observe the wood's transformation, and without the loss of his family's home. Now, he tells this story in a book to illustrate his very early love of experiment, and the fact that, to quote him, "My mind kept asking how and why, and that this characteristic had persisted from the beginning of my life." Perhaps there's no one definition of a great scientist, but maybe it's this capacity to ask questions and to pursue them persistently and with ingenuity that lies at the heart of it. And certainly proof of this thesis, if proof were indeed needed, is here before us today. For by any measure, Professor Zewail is a great scientist. Born on February 26, 1946 in the city of Damanhur, 60 kilometers from Alexandria, Ahmed Zewail recalls a happy childhood spent in the city of Dizuk. He speaks fondly of the influence of his mother and father, which they had on his life, and also of his uncle Rizq, who taught him, in addition to the enjoyment of music, an appreciation of critical and analytical thinking. Educated in Egypt and the USA, he did his undergraduate degree in Alexandria and then completed his PhD at the University of Pennsylvania and a postdoctoral IBM fellowship at the University of California, Berkeley. Following this, he then moved on to take up an appointment as assistant professor of chemical physics at Caltech in 1976. And this was the start of what has become an extraordinarily fruitful and fulfilling association with Caltech. Appointed the first Linus Pauling Chair, Chemical Physics, in 1990, he became the director of the National Science Foundation's Laboratory for Molecular Sciences, LMS, in 1996. He is currently the director of the Moore Foundation's Physical Biology Center for Ultrafast Science and Technology at Caltech. It was in 1987 that Professor Zewail published his seminal paper, which gave birth to the scientific field of femtochemistry. The challenge Professor Zewail faced, a long-standing challenge, was how you could observe atomic motions during molecular transformations. What in effect happens when chemical bonds are broken and formed, given the speed of change and transformation. Now, if I tell you that such transformations take place over a femtosecond, that's a millionth of a billionth of a second, you can see the scale of the challenge. But exactly in the spirit of the boy who took a burner, some wood and glass tubes all those years ago in Dizuk, Professor Zewail sought to create apparatus that might capture those movements. At the risk of oversimplifying a quite extraordinary challenge and an extraordinary breakthrough, He did just that, employing a laser technique which has been described as akin to the fastest camera in the world. He was able, as a result, to film molecules during reaction and the transition phase. And it was this pioneering work that led to the award of the 1999 Nobel Prize in Chemistry. Femtochemistry radically changed the way in which we understand chemical reactions. It has had an impact on all the branches of chemistry, and its influences and insights extend to biology and materials science. More recently, Professor Zewail has been working with his colleagues to develop the field of 4D electron microscopy for the direct visualization of matter's behavior from atom to biological cell in the 4 dimensions of space and time. But there's more to Professor Zewail than a pioneering and groundbreaking scientist. Professor Zewail has another passion, realized at the age of 21 when he was appointed as a demonstrator, Moed, and he taught undergraduates at the University of Alexandria. And that is the thrill and ability to explain science in the clearest way possible. As he says himself, and I quote again from his book, "I believe that behind every universal phenomenon there must be beauty and simplicity in its description. This belief remains true today." And he continues to be a tireless advocate and communicator for science. This drive to share his passion for science comes from a deep sense of what science and knowledge can do and do for all. There's nothing exclusive or excluding about his approach. Science, in his view, has the capacity to make a difference to humanity, the world we inherit and pass on. That's why it's worth, indeed essential, and ultimately so satisfying to pursue. That's why he believes just as strongly in the need to encourage the next generation of scientists to come forward. And that's also why he works with such energy to develop the public's understanding and appreciation of science. And it's because of these passionately held views and vision, his commitment to world peace through knowledge and understanding, in addition to his pioneering science, that Professor Zewail has received numerous honors around the globe. They include some 40 honorary degrees, more than 100 international awards, which include the Albert Einstein World Award, the Benjamin Franklin Medal, the Leonardo da Vinci Award, the King Faisal Prize, and the Priestley Medal. However, as an Egyptian with a warm and abiding affection for his roots and his country, perhaps most gratifying and significant for him are the awards of the Order of Merit First Class and the Order of the Grand Collar of the Nile, the highest state honor of Egypt. He has appeared on Egyptian stamps, which doesn't often happen in your own lifetime, and his own old school, high school in Dazuk and a street in Damanhur have been renamed in his honor. He's a global figure, and on April the 27th, 2009, President Barack Obama appointed him to the President's Council of Advisors on Science and Technology, and in November of the same year, he was named the first United States Science Envoy to the Middle East. He's an elected member of academies and learned societies across the world, and international prizes have been established in his name. In Cairo, the AZ Foundation is providing support for the dissemination of knowledge and for merit awards in the arts and sciences. In his book, Voyage Through Time, Professor Zewail quotes the scholar Dr. Taha Hussein, who observed that, and I quote, "Knowledge or science is like water and air," and notes that without water and air, you can't live as a human being. Science is Professor Zewail's water and air, and we are the beneficiaries. For his commitment to science, for his consequent achievements, and for his passionate belief and advocacy that science and knowledge lies at the very heart of who we are and what we might become, I will now confer on Professor Ahmed Zewail the honorary degree of Doctor of Science.
Thank you very much. Thank you.
Congratulations.
Thank you. Thank you. Thank you. Thank you. Thank you. Thank you very much. Thank you. Thank you, Principal, very much for the very thoughtful and kind words. And thank you all for actually coming. I have a small difficulty. I've been flying now for 24 hours from Los Angeles with some problems with the airlines. so I'm a bit out of phase, as we say in physics. But I will try to do my best to, on this very special occasion, which I consider it very special. This honorary degree from this university is unique, at least for me, because of the kind of things you heard from the principal that I am concerned about in the world of today. And this same university was a center of enlightenment, as you all know, in the 18th century. And one of the things that was striking to me, that among its distinguished alumni so far are 6 Nobel Prize winners and 2 prime ministers. And so my advice to this university is to continue to produce more Nobel Prize winners than prime ministers. But it's really remarkable in looking at Glasgow to see that giants of science have came from this school. And therefore, it is my great honor to be among the graduates of this particular school. I just count 4 for you. That probably because you're living here all the time, you don't know their own value. Of course, Calvin is very famous here. And Calvin have redefined the limits in physics and in all sciences. If you look at James Watt, you have to say that has redefined the Industrial Revolution, because without the steam engine, we would not be what we are. If you look at Joseph Black, he's a discoverer of carbon dioxide. So today, the whole problem of global warming, we would not have been able to understand what causes this without understanding a discovery such as carbon dioxide. And of course, above all, in many ways, is Mr. Adam Smith, because that actually is the key founder for the concept of the free market. So if you look in a place like this, I'm asking from my title, Revolutions in Science and Society, and you say, what makes a small place like this have a very high level of innovations? Simple questions, but not easy to answer. And in fact, I was asking the heads of the university before this ceremony, why Scotland in general is known actually to produce a very high level of innovation if you divide by the population of the country. So if I be specific and ask, what creates innovations in society in general and the scientific revolutions that we have witnessed for the last 400 years or 300 years? And in fact, I was on a recent official visit in Asia, and one prime minister asked me, what does it take to get a Nobel Prize for this particular country, which didn't have any Nobel Prize? And I think he was expecting that I would say, you need 10 buildings and $10 billion and get this and get that. And that's not what I said. What I said, search for the best minds and give them the atmosphere, and you will get Nobel Prizes. And the proof of my principle is, you look at Japan. When I was beginning a professor at Caltech, Japan didn't have Nobel Prizes. But Japan was on the rise in science and in technology, and they invested well, and today they probably have 10 or more. So why, if we found these minds and give them the right atmosphere, why are they able to innovate? The reason, in my view, is simple. And this is really contrary to what many governments are doing right now, even in the Western world, not only in the developing nations, but also in the developed nation. And the concept there is curiosity, intellectual curiosity. What made Mr. Calvin do what he did is because he was curious about certain aspect of what he was doing in research. And I wrote a piece, in case you are interested in, an editorial in Nature in this country, and I called it Curiouser and Curiouser, because if you go back to the major discoveries that have been made, they are not really too different from Alice in Wonderland. It's the same type of thing. You're trying to uncover facts, and in the process, you learn something about what is new. And I give you just two examples of this intellectual curiosity. One is from my friend Charlie Towns, who received the Nobel Prize for the concept, certainly for the discovery of the maser and for the concept of the laser, because it wasn't really Charlie who produced the first laser. But when you talk with a great man like Charlie Towns and you say, how did this idea came to you? Before that, we had Albert Einstein telling us what is the nature of the light. Even it goes to Newton and many others. But in the process, all what we know is that the light, as you see it, is incoherent, and there is something called spontaneous emission, and this spontaneous emission is always a killer of the process of absorption by the light. So Charlie Towns was sitting somewhere on a cafe and asking the question, can I flip this? These two processes, you don't have to get into the details, process A and process B. And in nature, always B dominates A. He was asking, can I make A to dominate B? Simple questions. So he started to play with a molecule called ammonia. Put in the molecular beam, did this and did that. As a matter of fact, his colleagues at Columbia University at the time recommended that he move on from this field because he would not get tenure, because it doesn't seem to be of interest. But he was convinced about his mission, and he's curious enough to continue on, and he found this whole phenomena that nowadays the expert knows, the role of the inverted population in creating the laser. And now we have a coherent laser beam that comes out that have created a whole revolution in science and technology. When I look back at my own development with my own group, as the principal said, I always was intrigued by how matter transformed from one thing into the other. In Egypt, we didn't have lasers, we didn't have all of these big new tools, but simple experiments one can do to satisfy the curiosity, and I did. But even having the opportunity in a place like Caltech, what we really was asking at the time is nothing big deal, or we know that we're going to get the Nobel Prize for it, or none of that you hear about in the media, or the government wants to people to do. I was so intrigued by an idea called coherence. And can we study this on the level of the atom? And can we really see the atoms in motion if we do such concept? One thing got to the other, one thing got to the other, until the 1987, when indeed we were able to see such motion. Now, if you go back into Western history, it was Democritus who said, or at least gave rise to the concept of the atom. Atomos. You cannot divide it anymore. but we never seen it in motion. Never seen the atom in motion. And there are all kinds of interesting concepts that the physicists will appreciate, because the atom, you cannot describe it by the language of Newton. You have to describe it by something called quantum mechanics, which is all probability. The atom can be here, can be there, can be there. And so if you have a probability like this, how can you photograph an atom unless you localize it in space and you make it in one particular place? And even the work, and this is what got the Nobel Prize, but even the work we are doing right now, I'm more excited about it than the work we did for the Nobel Prize. Because now we can actually see for the first time ever matter transforming in the 4 dimensions, which are very fundamentals, 3 in space and 1 in time. So, and it's not only these examples. If you look at major discoveries, quantum mechanics and the idea of Planck, looking at what he observed, relativity, the transistor, which transformed the whole world today, Mr. Shockley and colleagues, all of this came by asking some questions about how electrons move in the materials. So curiosity-driven research is essential, and the students might be surprised in the audience that 80% of American GDP is dependent on such technologies discoveries. It's a remarkable. You say, what quantum mechanics is good for, or what laser is good for. But at the end, that's really what moves the economy. But not in the way we are trying to do it, by saying, we think we can do it this way, therefore invest all the money in order to get into the market. So science, to me, is the endless frontier. It's as simple as that. And therefore, if you look at even today, the excitement that's going on, I mean, just think of our ability to visualize and control the atoms in space and time. Think of our ability to decipher the language of your genes and my genes today with great precision. Never were able to do that before. Think about the way we are going with communication. I just saw at the laboratory at Caltech, which we oversee, called JPL, I just saw what's called MSL, which is the Mars Science Laboratory. A remarkable vehicle, just the size of a car, that now will be put on Mars and try to get samples and analyze them with mass spectrometry, with lasers and everything. And believe it or not, the pictures that's going to be taken from there and sent to the Earth, it will take 17 minutes to come down to Earth. So we are not communicating between Glasgow and Cairo. We are communicating now between planets, and soon it may be between galaxies. So, is it the end of science? There are books that I read, which one of them actually was titled End of Science. The author claims that all the major discoveries have been made, including quantum mechanics and the like. And of course, you know the answer. This is naive and this cannot be. Science is an ocean of knowledge, and we're really uncovering just a few % of what we can do. And the example of this, you can go to astrophysicists and ask them, and they will tell you this whole universe that we are part of, almost 90% of it is dark energy and dark matter. So we only know at most 10% of our big universe. So clearly, the questions are vast and enormous. Until today, for example, we don't know what that dark energy means. I sit with some giants at Caltech in physics, and when you ask this question, we really don't know exactly what it means. We do not know the origin of life. Where did it begin, and how was it formed? And we are challenged by so many problems right now. Think of the food crisis that may happen to the world, climate change, and disease spread, and so the opportunities are huge, and one can anticipate a century of work to address these very important and exciting questions. But science and technology have extended now beyond the laboratory and the discovery and the innovation in the market. And I think this is unique to the 21st century. And that's what I want to end my address with. I don't think we anticipated this. None of us, at least I didn't. And that is the role of science and society in actually inducing and creating revolutions. We have witnessed this year a major revolution in Egypt and another in Tunisia, and in Libya we're seeing it, moving to Syria, what's the so-called Arab Spring. I witnessed firsthand the revolution in Egypt because I was one of the advocates for a long time that the regime must change. And so on the second day of the revolution, I addressed the nation on the television, on Al Jazeera television, saying for Mr. Mubarak, he must step down, with all due respect. But the country needed a new course. But what is remarkable, and I followed this, by the way, in writing by an op-ed in the New York Times, and in the Times of London also. But the key thing here about this is that when you personally witness that, not only it was a thrill, but it was for the first time in the history of humanity, I believe, that one can see the role of science and technology in making or creating new democracy. What they used, I sit with many of them, and I know many of them. These are youth, university graduates, or university students, at least the beginning of the revolution. And when you sit with them, you find that they are all communicating to each other by SMS and Facebook and stuff that I don't know much about. And so it is technology at its best. In fact, the government in the beginning of the revolution tried to stop this, tried very hard to stop this. And they didn't succeed because the technology was far superior. And in fact, because these kids know, or this youth know how to use technology much better than the government anticipated. I think in my generation, we probably would have used the stones and sticks and things of that sort. So there's also civility in the way they did it. It was so peaceful that is remarkable in 21st century to see that you have a revolution with hundreds of thousands, if not millions, on the streets and in the squares. And after they finish, they clean up the square and they regulate the traffic. I haven't seen in my reading of history that kind of civilized revolutions. There were no banners, one single banner I did not see in Tahrir Square that said, for example, this with this country, or we are against the superpower, or this or that. None of this anti-type banners existed in Tahrir Square. All the banners were saying, all messages to Mr. Mubarak and his regime. Many of them, we want a better life. Many of them, they feel very unhappy about the status of Egypt and the like. So it wasn't a revolution for against any major power or against certain religions. You could see the Christians and the Muslims, the young and the old, the men and the women. All of this was in Tahrir Square. I even witnessed a marriage in Tahrir Square. So there were all kinds of phenomena there, but all of them essentially were very civil. I think this revolution changed a dogma, which was done right. And this dogma is that, especially in the West, there is this fear of the faith of Islam. And I do remind them all the time that it was the Muslim civilization that lived in peace, actually, and acquired many of the Christian faith and Jewish faith in Andalusia. European Renaissance benefited from the the science that blossomed tremendously in Muslim countries. But in recent time, for political reasons, this has been used about conflict of religions and conflict of civilizations. These are theories that I find no physics in them. These are all used for political gains. And I believe that the revolution have demonstrated this very clearly, that these people are peaceful, they are not violent, they, in fact, toppled a whole system, which was Mr. Mubarak regime, in a very civil and peaceful. And I think that's why they got the praise from all over the world. So what is the cause of the frustration we're seeing in the world today? It's simple. It doesn't need a brilliant equation in physics. It's very simple. 80% of the 7 billion that are living on this planet Earth are in the population of the have-nots. These are very frustrated populations, but frustrated because of political biases, frustrated because of economic disparities. It doesn't mean that the rich have to go and be a poor and give their money, but you have to be fair. You have to be fair, and you have to see the other side of the equation, which you're dealing really with politics or with the economics of the world. And quite frankly, that's what we are not successful in doing, especially in the last 10 to 20 years on this planet. So with all of this, the science and technology trigger the revolutions of societies, and we are all hopeful. But also the revolution now is doing something for science and technology. And I'm very pleased to mention here today is that actually the government of Egypt has decreed in a unanimous vote on the formation of, on the outskirts of Cairo, of the city of science and technology, a whole city. And in fact, they are kind enough to name it Zewail City of Science and Technology. I think this is very exciting. It's going to be on 300 acres. It's already, there are buildings. I just announced in national television about fundraising, and one Egyptian gave 250 million. And the things are moving very rapidly, and it seems to me that that is an indication to me that people are now looking to the future. They are very hopeful about building their own country. And despite all the difficulties and all today in the Financial Times, there was an article about Egypt and the problems and this and that. But I think what one has to put in perspective, that Egypt is going through, and the Arab world is going through now awakening, and they want to get democracy, and they want to get their achievements and their history, and therefore there will be things like this. But I am really optimistic about the future, but I'm optimistic by nature, so we'll see what will come out. In closing, ladies and gentlemen, knowledge is the light of life. Knowledge is the light of life. And society that lose sight of the importance of knowledge are bound to live in the dark, in my opinion. And so it is a great pleasure to be here with you today and to be the graduate of this great institution. Thank you.